All right, so this is the project on planet orbits, building your working solar system. And these are instructions that you will find in the Word document. I'm going to go through some of these here. I'm going to start almost here in a moment. This is actually what you're aiming for, and then they would be moving these planets here. And I'm going to start over here because we need to use the trigonometry to put that orbit into 3 dimensions. So if I expand this one here, maybe, there we go, looks a little bit bigger. Then we have these orbital elements here. And rather than looking at this particular drawing, I'm going to move this out of the way. And we're going to go over here to Desmos in 3D. And so here we have a couple of orbits, one in red, one in green. The one in red here is the Earth, and then I have, and the green one will be the one for Mercury or in that neighborhood or anything. And then I have these sliders here for the orbital elements, and I'm going to show you what happens with these. So the first one here shows us that, hey, this is the size of the orbit. And I'm going to put it kind of like where Mercury is, about 0.4 the size of Earth. And I can turn this one around here, and we can see it's kind of flat there. And this one here is the eccentricity. That means how elliptical the orbit is. And notice that actually you have to go to very large numbers here to really make it elliptical. Turns out Mercury is actually around here. And when we take a top view, that although it's off center, which is actually caused by that eccentricity, it's still almost a circle. So that's one of the things that is a little bit surprising. I'm going to just try something here very quickly. Let's see. Oh yeah, that's better actually. So I'm going to look at these others here. So here we have the eccentricity. I'm just going to make it more elliptical than Mercury's orbit really is. There we go. And notice that this, whoa, where the planet is here, that would be the perihelion, so the closest approach to the sun. And that is determined by the eccentricity as well. Okay, the next one here is the inclination. So how the orbit is inclined, and you can see that what happens here. So like 45 degrees here, something like that, 43 degrees, we can see, yeah, that looks all right. And we're not going to go to 90, but I'm just going to show you. There we go. Now it would be pretty much upright, right? I'm going to go back and please stop turning on me. There we go. All right, it's all good. Maybe. It keeps turning on me. Gee, stop doing this. All right. Oh, I made it upside down. That's okay. Accidentally. It's all good. It's all good. Okay, then these others here. So this is a little bit extreme the way I do it here. I'm still really trying to stop it from turning on me and getting upside down. There we go. Oof. This one here, you can see where these nodes are, where it crosses the plane of the Earth's orbit, for example. And there we go. We can turn this. So you see how this one turns, the orbit. And then it also turns where the perihelion is in respect to that. So kind of around here. And I'm just going to use some arbitrary numbers here. This one here puts the initial position of the planet somewhere around, and I could have chosen negatives, then it would go the other way, either way. So there we go. When you do the actual project, you're not going to work with these sliders. I will show you very soon what you're going to work with. I just want to give you an idea on how this looks like. And then when I hit the play button here, you can actually see that, oh yeah, there's the planet orbiting. I didn't do that for Earth here. In my intro to orbits is what I call this one here, intro to orbits. Was a little bit too much, but you will see that once you have assembled your solar system. All right, I'm going to pause here so I can show you what you actually have to do. Actually, what I'm going to do is I'm going to make a second recording for this one here. So the first one was an intro to these orbits.